morning. This is section 6 review key. So we're going to go through all of the problems. So number 1, find measure angle B and E. We know this angle is compared to this angle. We know these angles, which are vertical, will be congruent, which means angle B must be congruent to angle E. Alright, so those are congruent. You have to set those two expressions equal and solve. 5x plus 34 is equal to negative 2 plus 14x. And solve. Alright, so we could add 2 over here. We have 5x plus 36 equals 14x. Subtract 5x over here. 36 is equal to 9x divided by 9, and x is equal to 4. We want to find the measure of angle B and E. We simply need to substitute 4 for x and evaluate it. So we have 5 times 4 plus 34 for B. And you have negative 2 plus 14 times 4 is E. 5 times 4 is 20 plus 34 is 44. And negative 2 plus 14 times 4 is also 44. They should be the same because they are congruent angles. Number 2, what information is needed to prove triangle MLK is congruent to PQR by angle side? There's an error on this review. This can actually be done in 2 different ways. So there are 2 different answers. However, on your test, you'll have 1 answer. So you notice, what do they both have in common as far as at least an angle? They both have 60 degrees angled. They both have 9, and they both have 9.5. However, we have to go in the order of angle side. So here's an angle. I could go up with line tag, hit the next angle 65 degrees, which would have to be over here. Angle, 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 and then after that we would have to hit the side using line tag. So 9.5 would have to be that side for angle side. So what do I need? I need the angle L, measuring the LB 65 degrees. That is one way. Like I said, there's an issue on this one. There's multiple ways to do this. You could also still start with the same angle. You would have hit the next angle, which would be 55 degrees. Have me over here where K is. And in that case, we would have had an angle, angle, and then we still use the same side. So again, angle, angle, and then still use the same side. So one other thing we kind of said was you could also have measure K be 55 degrees. Alright, so error on the review, no error on the test. 1.3. Given these two triangles are congruent, evaluate the following statements which are true. So if I'm going to do this problem, the best thing to do, I think, is to draw a picture. So I have a triangle, A, B, C, and I have another triangle in that same order, because the order matters. A and X have to be in the same place, so I'm going to put X up top, just like A. B and Y in the same place, and C and Z in the same place. Once I see that, now I see that these two triangles are congruent. You can even throw in some markings to help yourself. A tick, a double tick, a triple tick. Alright, you could also do angle markings if you want to. One arc, double, double, maybe no arc mark there, I don't know. Okay, so then if I follow what they say here, ACB, so angle ACB, we're talking about the angle right here, is congruent to YZX. So talking about the same angle. Are we talking about the same angles? Absolutely, that's true. Next, angle B and Y. B and Y are both double arc marks. They are congruent, so that is true. BC and ZY. Alright, so BC, B to C is a double tick segment, and Z to Y, still the double tick segment. Now I know that they flip the order of the letters, but they are still talking about the same side, so that is true. XY and AC. Okay, we're talking about 2 different sides, 1 tick mark, 3 tick mark, that's false, those are not congruent. And AC and XY. AC, XY, it's the same problem as above. You just flipped it, it's still false. Alright, 1.7, find the measures of the missing angle. So in the very last lesson we talked about isosceles triangles. We know they have 2 of the same legs, and then your 2 base angles are congruent. So if I look at this, it might help to turn it. You see the isosceles triangle right here, based on your markings here and here. So these are our legs, your feet are right below, thus those where your base angles are. So this is 72 degrees, this angle right here at 1 is also 72 degrees. And I want to find 2, I know there's 180 degrees in any triangle, I will add 72 plus 72. Mm-hmm. 72 plus 72. Take that, subtract it from 180, and I get 36. So measure angle 2 is 36 degrees. To find angle 3, I know 2 and 3 both are a linear pair. They are on a line. So around 2 and 3 is 180 degrees total. Now I know 2 is 36. I'll take 180 and subtract 36, and I'll get angle 3. 180 minus 36 is 144. You know, this top little angle sliver is 23 degrees. If I want angle 4 again, even that triangle there, there's 180 degrees. I'll add 23 to 144 and subtract from 180. So 23 plus 144. Subtract from 180. And I get 13. And there we go. So measure angle 1 was 72 degrees. Angle 2 is 36. Angle 3 was 144. Angle 4 was 13. Because there's no need for the degrees since they spell it out there for you. Next page. Okay, most classes, most groups were able to do 1.4 with me. If your group did not get to, it's because you're a little bit off task. So I'll go ahead and go through this quickly. If you already did this, then feel free to skip ahead to the next question. Fill the reasons to complete the following proof. AB is parallel to DC. AB is congruent to DC. So to show that, I will do little parallel markings with arrows. Tick marks for congruence. You want to prove N is a midpoint of DB and AC. So we're going to prove N is a midpoint of both of these sides. So with this proof, you're looking at this in general. They list a lot of statements. And number 5 is probably important. Your proven triangle ABM is congruent to CBM. So if it were me, I would go ahead and highlight those two. ABM, ABM. So this triangle in blue is congruent to CDM. Okay, CDM. And we're just going to come back. All right. So we're proving these two triangles, and I'll color them in yellow, are congruent to each other first. And then we'll get to the actual proof of what we actually are here to do. Okay, so if I start off, AB is parallel to DC. Why do we know that? If you go back up here, that is past the word given, thus that is my reason. So I find given, it's over here. There's my answer, given. Number 2, angle BAC, so we're talking about this angle, is congruent to DCA, this angle. Okay, so those two angles are congruent. Put A for angles. If those two are congruent, why? Well, if you have parallel lines cut by transversal, alternate interior angles are congruent. Okay, so these two angles are congruent. We'll label that angle. Why are they congruent? Is because when you have parallel lines cut by transversal, we're inside of those parallel lines we talked about inside the railroad tracks, so in the interior, and we alternate on either side of that transversal. Those two angles are congruent. If you look over here, if two parallel lines are cut by a transversal, alternate interior angles are congruent. So then if I find BDC and DBA, okay, BDC, so we're talking about the angle right here, I'm going to put a double arc, is congruent to DBA. DBA. Those two angles are congruent. Same thing. They're inside the railroad tracks, inside the parallel lines. Alternate sides of that line, that would be, if two parallel lines are cut by transversal, alternate interior angles are congruent as well. So we've got another angle. And now looking for, why is AB congruent to DC? Well, we already labeled that, and that was part of the given. So find out what given, that's the reason. And that's a side. We're saying AB is congruent to DC, so there's a side. Now, according to what we have proven so far to the judge, we went in the order of angle, angle, side. However, you must go according to line tag. I got that. So if I look at what I have here, this angle is congruent to this angle. This side is congruent to this side. And this angle is congruent to this angle. So if I play line tag, start away from all of those. I hit angle and side, angle. Same thing down here. I hit angle, hit a side, hit an angle. So why are these two yellow triangles congruent? It is by angle, side, angle. So if you would come over to the right and you find that angle, side, angle is right here. Thus, we go to number 6. VM is congruent to DM. So if I find VM, it's congruent to DM. So this guy is congruent to this guy. Why? And the other part, AM, is congruent to CM. Those pieces are congruent. The reasoning would be their corresponding parts. These are congruent triangles. So if we have corresponding parts of congruent triangles, everything is going to be congruent within those triangles. So look for something like that. Corresponding parts of congruent triangles are congruent. Right there. In the videos, they talked about an acronym. It's CPCTC. You might see either of these, either spelled out or the acronym. They're the same thing. This part, this specific piece won't come until after you prove two triangles are congruent. Once you prove two triangles are congruent, that's always when we'll use CPCTC. Now, why is M the midpoint of DB and AC? So if you go back here, why would M be the midpoint of DB? Well, you already just said this side segment is congruent to this segment. And M is the midpoint of AC. This segment is congruent to this segment. That is literally the definition of a midpoint. Both halves have to be congruent to each other. Alright, next proof. Complete the proof by filling the number blanks. Given BD is perpendicular to AC, and D is the midpoint of AC, prove BC is congruent to BA. Alright, so again, capital T here, upside down is perpendicular, so BD is here, is perpendicular to AC, which means 90 degrees. I can put a 90-degree angle over here as well. D is the midpoint of AC. D is the midpoint of AC. That would mean AD is congruent to CD. Alright, so let's go through this. D is the midpoint of AC. Why? It's given. When you look below, these are just all your options. So number 1, you probably just drag and drop given into number 1. I'm going to write them up here. BD is perpendicular to AC. Alright, again, that was given. So the next part. Top part, all the top boxes are all the statements. The below parts are all the reasons. Kind of like 2 columns, just called a mapping diagram. Or a flow chart. So I look next. AD is congruent to CD. Why? Well, we just talked about D was a midpoint of AC. So the reason why those two segments would be congruent is the definition of midpoint. That is down here. So you check. There's given, there's definition of midpoint. Here, this is the reason we need a statement. Perpendicular lines form congruent angles. Well, we did just talk about perpendicular lines. So what congruent angles are they talking about? If I come up here, we talk about these are perpendicular, so that's why the 90-degree angles are. So the two angles that are congruent are this right angle and this right angle. So if I was going to label that, maybe the top one would be something like ADB. That angle would be congruent to CDB. You look at all your options down here, they actually spell it out for you. Angle ADB is congruent to angle CDB. Just be careful, they try to throw you off with other orders, and the other orders are incorrect. I'm going to say it in shorthand here. I'm going to say angle ADB is congruent to angle CDB. That's what they said with words. Number 5, reflexive properties. We talked about reflexive is when two triangles share the same either angle or side. These two triangles share the same side, and it is DB. So I'm looking for something like side or segment ADB is congruent to DB. Well, if I look down here, they said segment BD is congruent to segment BD, same thing. So I'm going to write BD is congruent to BD. Alright, so all these were leading up to why these two triangles are congruent. So if you think about this, what if you told a judge, you said, hey, these sides are congruent, these angles are congruent, these sides are congruent. Don't just judge it based on what the flow chart says. Let's go based on line tag. So if I come up here, we said that this side was congruent to this side, this angle is congruent to this angle, and they share this side, so this side is congruent to this side. If I do line tag, I hit a side, hit an angle, hit a side. And in this case, it is side angle side. So the reason why we can see the statement is for side angle side, which is down here. And why then would BC be congruent to BA? Okay, so BC is right here, and BA is here. Well, these are corresponding parts of two congruent triangles. I'm sorry. These two sides are corresponding parts of two congruent triangles, which are congruent. That's that CPCTC thing again, right there. So right here we write CPCTC. These two triangles are congruent. I know there's these triangles here. Just pretend that those little triangles, there's no outline. They're just a way to put numbers over numbers. So if ABC is congruent to MPN, I would start off using some markings to help yourself. So A, arc here, is congruent to M, arc here. B is congruent to P. So here's B, congruent to P. And C is congruent to N. It's just to help us out. So then we go on. Choose a correct response to fill in the blanks. Because triangle ABC is congruent to NPN, there's a sequence of rigid motions. Remember, rigid motions are motions that map one triangle to the other and keep it the same shape. So that'd be like a rotation, a reflection, and a translation. Not a dilation. A dilation is a non-rigid motion which changes size. So, sequence of rigid motions that maps one triangle to the next. This is the same sequence of rigid motions that maps segment AB to what other segment? So if I look at AB, A, B, you go from one arc to two arcs. Up here, we would want to follow that same pattern. So from one arc would be M, to two arcs would be P, MP. So if I look over here, the segment MN, segment NP, segment MP. This is my answer. Next sentence. This means segment AB is congruent to, same thing, segment NP. Congruent segments have the same length. So the length of AB is equal to the length of, and they are being very redundant here, AB, NP. So right here, AB, NP. So AB is equal to how long? Well, AB is here, NP is here, they're the same length. So if NP is 6, so is AB 6. To find the measure of angle A, use similar reasoning to show that angle A is congruent to angle. Alright, so angle A and M are the same angle. So M. So measure of angle A, right here, is equal to what? Well, M was equal to 46 degrees, which means A was also 46 degrees. We know then, and the measure of angle C is equal to what? Measure of angle M, or N is equal to what? Measure of angle P is equal to what? Well, P is probably going to be the easiest one to find first. P has a double arc mark, and so does B. They're the same angle. So B is 78, so is P. I'm sorry, y'all are 78. You want C and N? They're the same thing. So honestly, we could just solve one of these triangles. It's going to work for the other one. You already know A and M are the same, so you could also go ahead and write 46 here. So we know there's 180 degrees in a triangle, so we take 180, subtract 78 and 46, and we'll be left with whatever angle N is. 180 minus 78 minus 46. 56 degrees. which means C would also be 56. So I come down here, 56, 56. All right, 1.9. The heights of two similar triangles are in the ratio of 1 to 5. And if the area of the larger triangle is 600 square units, what is the area of the smaller triangle? Okay. So area is squared. So all we're going to do is we're going to square both of these numbers. 1, 2, 5. Now we're talking about area. They say the larger triangle is 600 square units. So the larger triangle would be like the 25. 600, so the 600 would be like the 25. What's the area of the smaller if it's 1? So all we're going to do is take 600 divided by 25. That's 24. And 1 would be equivalent to 24. So basically the area would be 24 to 600. 24 to 600. These would be equivalent. Same type of idea. So the area of the smaller triangle is 24 square units. 1.10. Calculate the area of ABC with altitude BD given. B is 1, 3. D is -2, 0. And altitude is a fancy way of saying height. Alright, so like that. Round units in your cent if needed. Okay, so what they really want you to do is they want you to find the distance from here to here, which would be your height. And then they want you to find the distance here to here, which should be your base. And then they want you to find the area of the triangle, base times height divided by 2. That's nice. I'm going to give you a better way of doing this. So the hint is to find the area of the large rectangle around ABC. So highlighter, I'm just going to make a big rectangle around the whole thing. We're going to find the area of the large rectangle. Then what we're going to do is we're going to subtract the area of the right triangles on the outside. Alright, so if I want to find the area of the large rectangle, I know the area of a rectangle is base times height. So if I'm going to find this, okay, what's my base? Well, it looks like it's 1, 2, 3, 4, 5. And the height's 1, 2, 3, 4, 5, 6, 7. So I would take 5 times 7, and that is equal to 35. So the area of the rectangle is 35 units. Great, but I only want the area of the triangle on the inside. So again, what we will do is now we're going to find the area of these little right triangles here. And once you find the area of those right triangles, we'll add those together, subtract it from the area of the whole rectangle, we'll be left with the area of the triangle we need. So, I'm going to start off with this triangle here. We know the area of a triangle is base times height divided by 2. So this little guy right here, I'm going to say triangle 1. The base and the height. So base could be like, it's just upside down. 1, 2, 3, 4 is my base. My height could be 1, 2. And according to my formula, I divide that by 2. So 4 times 2 is 8, divided by 2 is 4. So the area of the triangle, the first one is 4 units. 4. I'm going to do the next triangle, triangle 2. Okay, so we're talking about this triangle here. Alright, base. 1, 2, 3, 4, 5. Height. 1, 2, 3, 4, 5. So 5 times 5 divided by 2 is equal to 12.5. And then I do the area of the third triangle. Okay. So I've got 1 could be my base. My height, 1, 2, 3, 4, 5, 6, 7. So 1 times 7, and then divide by 2 for my formula. 1 times 7, and divide by 2 is 3.5. Okay. So this was 12.5. This was 3.5. Now I know the area of the whole rectangle is 35. So I'm going to take 35, the area of the whole rectangle. I'm going to subtract every area of all the orange triangles. So minus 4, minus 12.5, minus 3.5. I'm going to be left with the area of the white triangle, which is what I want. 35. Minus 4, minus 12.5, minus 3.5, 15. Area of the triangle we need is 15 units squared. Portable basketball hoop, shown below, is made so that BA, AS, AK are all equal to 10 feet. The measured angle BSK is 64 degrees. Find the measure of AKB. So I'm going to go label all this. BA is here, it's 10. AS is here, it's 10. AK is here, it's 10. BSK is 64 degrees. So BSK, talking about the angle right here, is 64 degrees. Find the measure of AKB. Alright, so I want to find AKB. So we're talking about this little angle right in here. It's all about isosceles triangles. You notice right here you have an isosceles triangle. These are your two legs, which means the base angles are your feet are congruent. So this angle is 64. And your other foot, 64. Alright, we can go ahead and figure out the angle top here. You know there's 180 degrees in a triangle, so we'll add 64 to 64. That's 128. Subtract that from 180. That's 52. So the top angle up here is 52 degrees. Alright, I can keep going. We know on a line there are 180 degrees on a line too. Right here. Right at A. Right here is 180 degrees. You know 52 degrees is right there. So if I want to figure out the angle on the other side of this, we take 180 and subtract 52. When we do that, we get 128. So 128 is right there for this angle here. Hard to see. Okay. You know their isosceles triangle. It's right here. There's a leg, there's a leg, there's a base. Right here you have 128, that's that angle above. So if I want my feet angles, which is the blue one, and that's what I want, I'm going to take 180, subtract 128. I'm going to divide by 2 to get both of these angles, and thus getting what I want. So again, I'm going to take 128. I'm subtracting it from 180. It's 52. I'm going to divide it by 2 for my 2 feet, and I get 26 degrees. So, question mark is what I want is equal to 26 degrees. So what would this one be? 26 and 26. But that's what we want. That is equal to the measure of A, B. .2, 12. Using your markings, I would go ahead and label your S's. Label these S's. The one other piece that they don't tell you, but assume that you know, is that vertical angles are congruent. So this angle here is an angle, vertical. Right here's a vertical angle. And there's my NA. So if I place a line tag, I hit a side, an angle, and a side. Side and a side. Alright. This one is Algebra 1 in its finest. It's a system of equations. What I do know about this triangle is an isosceles, which means this angle is congruent to this angle. They're my feet. So one equation you could say would be 4x plus 2y is equal to 70 minus x. That's one equation. Another equation you could say is, well, if these are all angles, we know there's 180 degrees in any triangle. So I could add all of them, 6y plus 70 minus x plus 4x plus 2y, all equal to 180. So where I go from here for the algebra, you can either use substitution or elimination. I am a big fan of elimination, so that's what I'm going to do. And for elimination, all your x and y's on both equations have to be on one side of the equal sign. So on number 1, I'm going to add x over. These cancel. So now I have 70 is equal to, over here, 4x plus 1x is 5x. That's 2y. Alright, so here's my new equation number 1 in blue. Doing the same thing with this. Well, here's my equal sign. I want all the numbers on this side. So I'm going to subtract 70 over. Okay. And if I do that, those cancel. And 180 minus 70 is 110. Over here, I'm just going to combine my terms. So, let's see, combining negative x and 4x is 3x. And combining 6y and 2y is 8y. So here's my second equation. So with elimination and algebra, you put these two equations one on top of the other. So I have 5x plus 2y equals 70. And I have 3x plus 8y equals 110. If I want to solve this with elimination, you have to eliminate a variable. So you can eliminate either x or y. You just need a number that they both divide evenly into. So like y's, I would eliminate because they both divide into 8. 8 divides into itself, and 2 divides into it as well. So if I want 2y to become an 8y, I just want it to be the opposite. I want it to be negative 8y. I'm going to multiply this whole front equation times negative 4. Watch what happens. Negative 4 times 5x is negative 20x. Negative 4 times 2y is negative 8y. Negative 4 times 70 is negative 280. And I haven't touched the bottom equation, so I'm just going to rewrite that out. 3x plus 8y equals 110. Looking at these pink equations, now you add down straight down like your old school. Negative 20x plus 3x is negative 17x. These cancel. Here's my equal sign. I add these. Negative 280 plus 110 is negative 107. Now we just solve this. Easy. Divide by negative 17. These cancel. And x is equal to positive 10. Great. So then I also need to find y. If I'm going to find y, I go back to one of my equations that I started with and resubstitute 10 in for x. Doesn't matter what equation you use, just matters that you use one. You're more accurate if you go with the very first, 1 or 2. Okay, so if I choose, say I'm going to choose this equation 1. 5x plus 2y equals 70. So 5, replace the x with 10, plus 2y is equal to 7. Solve for y. Solving, subtract 50 over. And 2y is equal to 20. Divide by 2. Y is equal to 10. Boom, shakalaka. Last page. 1.14. Analyze the triangle ABC below. What is the perimeter of triangle ABC? Triangle ABC. Okay, so this is still kind of like that one with the rectangle around. Same idea. If I want to find the distance of AB, what we did is we used A squared plus B squared equals C squared. The Pythagorean theorem to find distance. With that, you need a right triangle. So with this, I'm just going to draw my own right triangle. There's my right triangle. A and B are always the sides off the right angle, and C is what we're going to try to find. So if I was going to find this first, the distance of A to B, go ahead and use the Pythagorean theorem. I got 1, 2, 3, 4, 5 blocks here, so 5 squared, plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blocks there, 12 squared. And I'm trying to find C, which is this side. 5 squared is 25, plus 144 is equal to C squared. Add those together, it's 169, square root. And C is nice and pretty, it's 13. So the distance of AB is 13. We gotta do that with all the other sides. Now maybe this next one right here, we do a small triangle. Count your sides. That's 4. 1, 2, 3, 4, 5, 6. That's 16 plus 36 equals c squared. Adding those together gives you 52, the square root, and c is equal to whatever the square root of 52 is. I'm going to leave it the radical of 52 because I want to leave the most exact answer up until the end. So right now I'm going to put square root of 52 right there. Last one, from B to C. Make your right triangle. Figure A and B. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 36 plus 81 for c squared. Add those together. $117. Square root. So square root of 117 is equal to c. Alright, so this one's 100, square root of 117. Okay, so again, they want a perimeter. We're just going to add these three numbers up, and then we'll round if they ask, which they didn't on our review, I apologize. So let's go to the nearest 10. So if I add those numbers, 13 plus the square root, that was second in this button, 117, scroll out, plus square root of 52, scroll out, press enter. My calculator is going to eventually give you a nice simplified radical version. We want decimals again, hit the arrows. 31.02. So if I said the nearest tenth is at the 0, but we use the 2 to help us round. It's not big enough to help us round, so your answer is 31 units. Not squared, we're not doing area, just units. State if the triangles are congruent. If so, what theorem or postulate? Alright, so this is all with the angle, side angle, side, 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 angle, side, angle, angle, side, or side, angle, angle is the same thing. Or we talked about the HL. So remember, HL is a fancy one where it's ASS, but it's only when the angle is 90 degrees. We will never use ASS, ever. Ever. Or SSA. Okay, so you revert that, the same thing. We don't use that ever. Only use in terms of HL. So if we look at here, first one, I'm going to label everything, right? You got an angle here and an angle here, a side here and a side here. And these two triangles share this side, which they don't have to mark, but we will. And from there, we play line tag. So start away from everything. Here's an angle over here, way over here. I hit A, hit a S, hit a S. And that spells a naughty word right off the bat. So I check, is this angle showing a 90-degree angle? It is not. So, no, those triangles are not congruent. Number 2, angle, 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 and then they share this side. So if I go in order, an angle, a side, angle. Same as on the other side. That's good. That's one of ours over here. Angle, side, angle. So the answer is yes by angle, side, angle. We're going to keep going. Side, 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 side. So that would be yes. Yes by side, side, side. Angle, angle, side, side, and they share these vertical angles. Got into those. If I do line tag, I get an angle, a side, angle. So it's yes. Angle, side, angle. Number 5. Have an angle, have an angle, have an angle, have an angle, have a side, have a side. If I go in order, start way over here, I hit a side, an angle, and an angle. Or you can go an angle, angle, side. And that is one of ours. That's okay. The answer is yes by one of those. Okay, here we have a right angle and a right angle. I have a side and a side, and then we have vertical angles. If I do line tag, I hit angle, side, angle. Angle, side, angle. So it's yes. By again, angle, side, angle. Look, here you have a side, side. Then I hit an angle, but my angle's not in the same spot. And then side and the side. So I see all the markings are congruent, they're all right markings. However, something's wrong. Something's misplaced. If you notice, if I did line tag on this one, I'd hit a side, angle, side. If I did line tag on this one, I hit an angle, side, side. The order's not the same, the spell's a naughty word, so regardless, no, they're not congruent. Number 8, you got all tick marks, all the same, it's yes by side, side, side. 9, side, 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 angle and angle. Line tag, side, angle, side. Number 10. Side, 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 side. They share this side. It says yes, by side, side, side. And 11. You have a right angle and a right angle. You have a side and a side. Side and a side. Everything lines up. My line tag goes angle, side, side. Spell's another word, but we have the right angle, so we don't use that one. We call it HL, but it is yes by HL. All right. Good luck on your test. It's next class.